Hi everyone. So I am Pawan Bhardwaj. So I am from Google. We are part of gRPC open source maintainer team in Google. So we have like pretty basic talk today, like service mesh fundamental. I have with me Kannan as well, who is also from Google. He is a Java side of gRPC. So gRPC, some people might know, some people might not. It's like multi-language thing. So we have a repo for CPP, Python, and Java, Go, and other languages as well. So today we will just dive down into some of the fundamental things. Like we will not go too much into depth, but it's just like overview of like what the service mesh is, how it came into picture, and like what is the need of it, and how it is evolving further, and where does gRPC come into all of the picture. We have like some part of that as well. Okay, so service mesh, it's like very difficult to define. Like if you ask someone, like each person can make up its own definition. So for today, let's stick with a collection of horizontal scaled microservices whose nodes are connected by the network infrastructure that manages connectivity between them, right? Now it's like very complicated thing. So let's try to break it down a little. So first part we can see from the definition is the microservices, right? So what exactly is the microservices? So microservices, you can think of it like earlier we used to have like a big chunk of program which have like all the components stuck into a monolithic architecture. Then you have to deploy a whole thing again, like teams are like trying to deploy in the same binary and other thing. That was causing the issue. So what happened was like each team took a ownership of his own component and divided that into a smaller services. So which is like a microservice architecture, which most of the people here know. Now the problem which arises is now you have like microservices, you want to have load balance between them. You have to be prepared for disaster recovery, like okay, some cloud went down, does my application stop? So you have like multiple pods deployed in various regions. For example, in this example we can see US East 1, US East 2, we have like two thing of card, two of account deployed. Now problem comes, okay, you have like, okay, I have prepared for load balancing, I have prepared for disaster recovery, but client, how would client know which to connect? Like which pod does I send my service to, which is busy, which is not busy, how do I do load balancing? So what people started using was, okay, I will create a library. I will create a library which handles this logic, I will configure it, and that will do it. But that will not scale well. You need a library for each and every application. You have to maintain that library. And so that was one problem. So what came is, became the sidecar. So Envoy actually started it. So there was a sidecar pattern. So what you are doing now in a single container, you have like your application and proxy running side by side. You have like a single life cycle, you are running it, and proxy is handling it. So you are configuring proxy, and proxy is managing all this configuration, where it is trying to go, how it is trying to connect to other thing, right? Now if you see this diagram, okay, proxy is managing everything, and your application doesn't have to be stuck to that language of the proxy. Proxy is the separate thing, right? It could be written in C++, your app could be written in Golang, right? But problem is, okay, now we have like 4 proxy, 100 proxy. Now how do I configure this all proxy together? So that became, so that becomes the service mesh completely when we add a brain to it. So let's look at some of the advantage and disadvantage with respect to proxy, which proxy solved. So for example, what was a use case for them? So it's like easier life cycle. Whenever you're deploying an app, you deploy a proxy. So you get along with a container. It's a single tenant, so you have running it inside a container, so there is like not much issue. Easier to scale and schedule. As your application is scaling up, your proxy will be deployed with him. So it's not like you have to load balance, okay, is my proxy very busy or not? Yeah, your application can manage it. What is the drawback? You are sending it to a proxy, and proxy is handling all those things and going it out. Upgrades are a challenge. So let's say there is a vulnerability found in a proxy. You have to have a life cycle for that proxy. How will you upgrade? How will you make sure like that remains up to date? Plus, you are already doing it for your application. So now you are doing for 2 things, right? So these are, and there is an additional overhead. Now you are actually doing an extra hop on the inbound and 1 extra hop on the outbound. Like your traffic goes to a proxy, then proxy send it out. So there is then extra hop. in both the cases. So let's jump back a little and see like how these proxies are getting configured. So it started with XDS, which was said to be like Envoy Proxy API. And this API is kind of a protocol. So just to give a brief, so XDS means discovery service. X stands for it can be any type of discovery service, listener, resource. We have details of this further in the slide. So this is the Envoy proxy. It's kind of a brain of a service mesh. It's trying to configure all the proxies to have like configuration send out to all these proxies to work together. So this is a typical diagram we have. Like we have a downstream, then Envoy proxy. It is going to application, and application send it again to Envoy proxy. Envoy proxy does some magic, like where it needs to go. And the other side, the same thing happens. Now we can think like, okay, how this Envoy proxy getting configuration is from the XDS control plane. So from XDS control plane to this Envoy proxy, XDS client is nothing but inside an Envoy proxy. So that has like all the logic to connect to which server you give it at the time of init. So this is the typical diagram which people have of a service mesh. Now there is a gRPC version of this diagram, which is like kind of a proxyless service mesh, which some people might not know, like based on the booth feedback we were getting. So what happens here is, if your application is a gRPC application, gRPC can understand this configuration which we get from the control plane, Istio control plane. It's the same configuration which Envoy gets. So that gRPC can also understand. So even in Google Cloud, when you try to deploy your services, you will get an option like, how do you want to deploy? Do you want to deploy with Envoy proxy, or do you want to do a gRPC proxyless? So what do we mean by proxyless is, you will not have that proxy additional thing. So this XDS client, what we show here, is actually integrated in the library. You just have to configure it, similar to configure what you were doing for Envoy. So it's not a additional configuration benefit, configuration overhead. It's the same configuration, only instead of configuring your Envoy, you are doing the same configuration for gRPC. Okay, so how do I enable it? Like, okay, gRPC can understand very good, it can do, but how will I start using it, like if I want to use it? So for example, for name resolution, right? So right now, for gRPC application, you people might be, like there are like 2-3 URI scheme with gRPC support. So I'm taking an example. So let's say our services is example.com running at this port number. So how typically we give it on the client is like DNS and then example.com with port number. So this tell us, okay, send it. So then it will be sending to proxy, and proxy will be handling other load balancing stuff. So if you just replace this DNS with this XDS name, so what it in turns is, it will activate the part of the gRPC library which does this XDS client handling with server. So that will get activated. So then like from this name, this example.com, we will able to identify from the server's configuration, okay, where is the example.com, what are listeners, what are the clusters, where it is deployed, and that load balancing and other stuff, whatever you have configured in your control plane, we will be able to get, and we will be able to forward according to that. How these all configuration and what is the flow of the configuration, that we have further in the slide. Okay. Now bootstrapping. So bootstrapping, you people might already know. You might be doing it for your Envoy proxy. Like when a proxy getting started, it needs to know. Like for a service mesh, you are making a service mesh. You have your pods ready. You have like clients, server, everyone connecting to each other. But from where this Envoy proxy know, where is that control plane? Like I need to know this control plane, that initial kind of a configuration. So that constitute a bootstrapping. So in gRPC as well, you can give this bootstrap file. So there is an environment variable with gRPC provide, where you just provide this path, which is a JSON file. I think it would be similar to Envoy. I have not looked at it. So what is the important field here? So you can see this server URI, right? So it tells us gRPC client, like where is that control plane server located? Like from where will I get the configuration? Where to contact to get the configuration for this service mesh? Then there is a unique ID. Okay, what is my unique ID? What is the cluster name? Then there is a locality as well. Okay, I am in US Central 1. So it may be the case like, okay, servers are deployed in US Central 1 and US West region. So whenever we will tell this, okay, I am based on US Central, so the control plane will think, okay, this client is in US Central, so let me give him US Central 1 as a priority 0 and US West 1 as a priority 1, so that like you connect to your local locality and be a little bit faster. So these all things, like, it's same feature which Envoy has. It's not like something gRPC only have, but we are just showcasing like gRPC can do the same thing. And this is like kind of a basic of service mesh. So what are advantage we are getting if we are using a gRPC service mesh? Like, where does it make sense? So one is like reduce infrastructure complexity, right? Like, you don't have to deploy two different things. You are just making your application, and your application is already a gRPC application. So you don't need to put like extra effort, like doing something else. It's already part of library. You are just activating it using that initial part which we told, right? Like, just replace DNS from XDS and have that bootstrap config. You get a performance benefit. So for performance benefit, I want to clarify, it's not like we are able to do this feature faster than Envoy. Like, Envoy is also doing faster, we are also doing faster. But because we don't have that extra hop, so that extra hop is actually the saving part for us. And because Envoy is not running, you get a CPU advantage, like less CPU would be used. Because that extra hop is not there, you will get a latency advantage, and in turn, like a higher QPS for your things. Existing gRPC benefits. So gRPC already have like this authentication, authorization, and other things, so it seamlessly integrate with XDS as well. Compatible control plane. So this is also an important part. So XDS earlier used to be like only Envoy. I think now all of the service meshes have started supporting it. So even gRPC, your configuration would not be very different from the Envoy thing. So it's not like Envoy have like this kind of configuration, we have like some other kind of configuration. It's like one-to-one mapping. The same kind of configuration we also support. So it's the same control plane. So you don't have to change your control plane at all. What are the drawbacks? Like, okay, everything very good, but why, what is the catch? So catch is, this is not suitable for if your workloads are non-gRPC workload. Let's say you have an HTTP application sitting behind a proxy, you cannot use the gRPC proxyless in that case. Other is, some would say like it is combining the service mesh with your application a little bit, but point is like it's still in the library. You don't have to do these things manually, and library is taking care of it, but still it is part of your application which is running. So if that part crashes, your thing crashes. But I think that is similar for Envoy. Like if Envoy logic crashes, it's anyway will stop the RPCs, right? So XDS, how it has evolved is like now it's not like an Envoy proxy API. It's kind of a universal data plane API, which we are also supporting, and I think other services mesh is also supporting. So whatever new features comes up in XDS Envoy, we try to support it together. Like we try to, so there is like in parallel development, like okay, some new proto or new rate limiting method comes, and there is a Envoy team supporting that. We in gRPC also try to integrate it into our library. So the people who are using the Proxyless gRPC will also get the similar amount of feature. So let's go deep. I think Kannan will take you deep into this XDS protocol and how does this map and how does this load balancing thing work. So that is like second part of our presentation.
Yeah. Thank you, Pawan. We'll talk about the structure of XDS and what it is. There are two main parts of the XDS. It's basically an API, so there is a data model, which is a set of configuration, resource types, and fields that they contain. And secondly, there's a transport protocol, which is the mechanism that is used to get the resources to the client from the control plane. The transport protocol is general purpose pub/sub protocol. From the perspective of the transport, the contents of the resources don't matter. The gRPC client will have a bidirectional stream and can subscribe and unsubscribe to resources, and server can send updates to the resources when subscribing, and as and when any resources change, it sends updates to the clients. So it's basically all about discovering. So the X stands for the type of the resource. We have 4 types of resources: listener, route, cluster, and endpoints. So it's about discovering those resources. The URL that, as we talked about, the URL to connect will have the listener resource name, the XTS scheme, and then you have a listener resource name, which is a virtual host name. In the case of Envoy, this was the address the proxy listened on, whereas in gRPC client, which is not a proxy, we use it to indicate the virtual address to send the traffic to. So it's basically a user-given identifier for a service, which will be ultimately resolved through a sequence of resource types and ultimately result in the endpoints that you want to connect to. The listener resource will have a name of the route resource, which is a route table or route mapping based on the path and header matching or some other rules. It can be configured to also split traffic between clusters, or all the traffic can be going to a single cluster. It can also have retry and timeout configs for the RPCs going through that route. Thirdly, we have the cluster resource. A cluster resource represents a deployment of a service, of a backend service. There can be different versions that are deployed, so there can be many different clusters, one for each version, or if it's just a one version, there's just one cluster. And this resource is what specifies the LB policy to use among the endpoints of a cluster. So endpoints are the actual service instances that are present in the cluster. It can load balance among them. And it also specifies the TLS or the SSL, the security config, the MTLS or TLS security configuration to use when establishing the connection to these endpoints. And also a number of other parameters like the maximum concurrency that is supported by the services in the cluster, etc. And endpoint is a server instance such as a Kubernetes pod. It has an associated health status. And an endpoint resource in XTS is basically a collection of all the endpoints in a cluster, which can be across localities. For multi-locality cluster deployments, you have endpoints coming from different endpoints. And localities can have priorities. So depending on the location of the client that is requesting these resources, so based on co-locality, the priorities will change. So localities, so it's basically an arrangement of the localities, and then there can also be weights specified per endpoint for a cluster, so as to make a weighted round robin. So basically, we do a round robin among the endpoints in the cluster, and then we can also apply some weights in addition to a simple round robin. So these resource, whatever is specified in the resources, will be used by the load balancing policies, which will also go through briefly. So in XTS, so as we saw before, the XTS resources are resolved through any URL with the XTS scheme has to be resolved through an XTS name resolver that is implemented in gRPC. And this resolver uses the XTS client, which is what establishes the streaming watch bidirectional connection to the XTS server or the control plane. And using the resource definitions that are obtained, a tree of XTS load balancers will be constructed for the channel. And so that these load balancers can implement load balancing among the RPCs that are sent through the channel. And these load balances will account for the priorities of the endpoint localities, and also their weights and any other custom configurations that are specified through the load balancing. So there's a tree of load balancers that are constructed, and then the bottommost, the actual connections, like the TCP connections to the sockets are established, initiated by the bottommost one, the leaf load balancer. So they are initiated, and then they're propagated up and then the load balancing from the higher ones up the tree will get applied. So we'll go through that briefly in the next slides. And this load balancing is done on a per RPC basis. So each RPC will go through the load balancing that has been established for a channel. Now, this is what an integration of the XTS with gRPC looks like. It maps the concepts of XTS APIs and integrates it with the gRPC client channel design. So there is the XTS client implementation on the left, the one that says talks to control plane, the gray box on the left. So that talks to the XTS server over a bidirectional stream. And this is used by the XTS resolver when resolving an XTS URL target, and which happens at the time of channel construction. Basically, when you create a channel with a URL, the XTS resolver uses the XTS client to initiate fetching all these resource definitions from the control plane. And so it then resolves the service name to get a listener resource from the control plane. And then it gets a routing resource that we saw, the 4 types of resources that we saw earlier. So they are obtained in sequence. The routing resource, and then the cluster, and the endpoint resources. And these are used to set up the LB tree in the channel before handling the RPCs. So there is a, on the right, you see the LB tree. This shows the RPC handling. RPC handling that using these resource types, the routing picks the cluster based on the RPC path or header or the cluster weights. It can apply traffic splitting between like different versions of a deployment, for example. And then comes the cluster load balancing policies. So here is where the real load balancing starts. It can also apply any other security configurations to use for the connections and everything, like the TLS configurations and everything. So there, a cluster is made up of endpoints that can be in different localities. So the locality weighted round-robin load balancer policy like picks localities from the EDS locality list. So it basically applies the prioritization and the weights that are to be applied to the clusters that are specified by the endpoints, which is a weighted round-robin. So once it chooses the endpoint, and then it also it then goes through it applies the child load balancing policy that needs to be applied for all the endpoints within the locality. So locality is picked based on weighted round robin, and then we have the endpoint picking based on like a custom or a so it defaults to round robin, but any different load balancing policy can also be specified to use for the cluster. Now we have, this is the top-level overview of the various different service mesh features that we have. We have load balancing, security, circuit breaking, which is like limiting the concurrency, maximum concurrency, and there is also custom load balancing policies that can be applied, and then observability of collecting various metrics about retry stats and like connection breaking or reconnections and those kind of thing. And there is also outlier detection, which is like when after establishing the connection, if there are continuously failing RPCs, there are mechanisms for detecting. We have ongoing work to catch up with Envoy. Like we have feature gaps and we have work ongoing to cover areas that are missing, and this will give an overview of all the features that are being or have already been implemented, and new features are always being developed. Now, how do you actually use the control plane? So, as Pawan talked about, we have the management plane and management plane which is used for configuring the control plane, which is like a KRM manifest which you can use to configure the control plane. And the control plane in turn configures the data plane, like the RPCs that actually go out. So the control plane configures the control plane. Now, the data plane is the most critical part because it needs to be fast and it happens on a per RPC basis. So it needs to have higher availability requirements than the management planes. It's more performance sensitive and requires higher throughput than the management planes. The control plane does not actually touch any packets or requests to the system, but it only configures with the resource definitions to be used for the channel. And finally, the management plane is a flow path, which is the manual or offline configuration that happens for the control plane using Kubernetes manifest. So this is a popular example of how using the Istio for the control plane, and that's managed using KRM. So basically here the Istio configures the control plane, which can be gRPC clients or which can be Envoy proxies. So this slide is the same one that's implemented using Google Cloud. So for management plane, you have the Google Cloud Gateway APIs or gcloud commands. For the control plane, you have the traffic director, and which can configure the gRPC clients on the data plane on Kubernetes clusters.
So we already have a demo for Proxyless service mesh. So one point to note is this is not kind of a Google product, like gRPC is CNCF based. So all the mesh feature and whatever we have talked about, these all are available in open source. We try to entertain new feature, if you feel like you are moving from Envoy and want that last bit of latency and performance benefit and you are not getting that feature, you can raise a request, even implement it yourself, help the community as well. So we have a booth as well where we are showcasing this gRPC Proxyless demo and explaining it more in depth. So in short, we are using the same control plane. So we are getting the same configuration which Envoy is using, but we are processing it inside the library, in gRPC library. So if your application is already a gRPC and you want that extra bit of latency and extra bit of performance, you can try to use that. So yeah, we actually ended early. So any question anyone have? Okay, do we have mic?
Yeah, hi. So in case of envoys, we can use envoy filters and other things. So can we use this in the application side as well without any changes?
Okay, so you meant to say HTTP filter and these things?
Yeah, we have multiple envoy filters. We can extend the functionality.
So maybe I can answer it in generic way so that it answer other thing. Whenever you use these kind of envoy functionality like retries, filters, authentication, how do you configure it is using a control plane, right? You configure your control plane and control plane gives that configuration to Envoy and then Envoy enforce it, right? So same thing is happening here. You will still configure in your control plane. The control plane will still give that configuration. But only thing is instead of Envoy enforcing it, we will have that in our application, and our application gRPC library itself has the way to enforce it. So it's answering all the questions in that scenario. Yes.
Hey, so when we talk about the network layer of mapping, right? When we have many-to-many mapping, when services are talking intermittent,
I'm not able to hear you correctly.
Is it? Yeah. So when we have many-to-many mapping in the network layer, when services are talking in multiple ways, right? So in the specific cases.
So that is the case. Service mesh is that you have multiple client talking to multiple different pods running all together, right?
Yeah.
So that is the use case of control plane, like Istio or traffic director. They are the responsible to identifying this through NAC controller and another thing and get this information and they compile it, and whoever asks for it, they respond to it. So for example, in that case, right, like example.com. So as soon as we try like, okay, XDS example.com, we send this request to that server, that control plane server. We are interested in sending a RPC to this client. Do you know the address? Like, do you know which locality it runs? Do you know which cluster? So like what XDS structure was mentioned, right? That was given to us by the control plane, and we then route our traffic internally based on that cluster. We will have that all the logic built up inside, and then we will send out that RPC directly to that. Like you will not have that extra hop, but that processing which Envoy is doing after getting a configuration, we will pre-do it and then make a mapping and then do a per RPC kind of a thing.
So it would be like a cached discovery mechanism.
Not cache, like it's exactly similar to how Envoy would be doing, right? You are getting some configuration like which all localities and these you will make a map, okay, this is my locality, this is the priority of a locality, and when you are getting an actual RPC call for that service, you will see that tree, and you will just, based on that tree, you will just very quickly evaluate it.
Got it. Thank you.
So that configuration that is fetched is existing in the channel. It's sort of like you said, cache. So like as long as RPCs continue in the channel, so they will be reused.
So it's like kind of a gRPC concept, like wherever you want to connect, you pre-establish a channel so that like at that time, like you can just simply send the RPC.
It just establishes the stream and just gets that done. Okay. Got it. Thank you.
Okay.
Okay, thank you for this session. I have two questions. One, in case of Istio, right, if I want to exclude any specific CIDR from not going through the proxy, I can just use an annotation. So how that would work in this case?
I didn't understand fully, but let me answer in generic way, and you can think like if that answer else you can ask.
So ask him to come forward.
Yeah.
It's too far.
So basically, Istio is a control plane, right? Like we are not touching anything there. Like it will do whatever you are configuring there. Istio is pushing all this XGS configuration to the Envoy proxy, right, or some other proxy which you might have, right? This same configuration, when you're pushing to Envoy proxy, it is doing a particular way of routing that request, right? So same configuration you will still do on Istio. You will still get that same configuration, but you will get it in your client, gRPC. And then gRPC will do that same logic where to route your request. So it's like nothing specific for like whether it is running behind a proxy or without a proxy. Like if you just put an Envoy and remove Envoy and just put gRPC proxyless, you will not see any change because configuration says it, right? Like where to send it. So Envoy is acting on it, now we will act on it.
Okay. My second question is, if we move into a proxyless board, will it affect our upgrades? Because if I want to independently upgrade my Istio, it's possible now. My control plane and both the sidecars can actually go to a latest version, and my application doesn't have to be touched in any way. But if I go into a proxyless mode, then probably I have to update my gRPC client to match the latest version, or
no, that is actually, you would be more advantageous because that is actually an advantage of proxyless. Because right now, if you have a proxy and you have your application, you need to maintain 2 upgrade cycles, one for your application, one for your proxy, right? If you move into the proxyless, like you will anyway be upgrading your application with latest gRPC version. So as soon as you move to a latest gRPC version for your application, you will get all those with free. Like you don't have to do a separate upgrade cycle for that.
No, but will that mandate for me to upgrade my control plane as well? So let's say I move into the latest gRPC client. Will there be a backward compatibility that will still work with an older version of control plane?
Okay. So if you see like gRPC, we don't do any major releases. Like there is no breaking changes that has been done. Like it is still working on 1 dot. Like we have not even released a 2 dot yet. And on the basis of for XDS functionality, so as soon as you move to a new version, you still have the older functionality plus you have like new features which are coming in. So let's say you have an application which depend on a gRPC library and you are making some change. You would be anyway time to time doing that gRPC library version upgrade, right? So that would in turn give you that XDS configurations as well.
Okay, and my last question. So in the latest version of Istio, they support ambient mode where you don't even need the sidecars. So basically everything is taken care at the L4. How would that compare against this one?
I think ambient one, I don't know fully, but I don't think that has the XDS kind of a related thing that uses some other mechanism. So that is like not related to this part. Like we will not be able to handle it. So gRPC library right now only handle like XDS kind of protocol, which like if you want to map it, like it kind of envoy proxy thing. So it will not do any Z-trace and other thing. They have like, I think layer 4, layer 7 thing. So we are doing it at layer 7 only.
Okay, thank you.
Yeah, thanks. I think we are done. So yeah, anyway, catch us on booth if you have like further question or like we will be available. Sure. A Google Cloud booth, we will be in Google Cloud booth. Okay. Hall 4 Solution Showcase, Google Cloud booth. Okay, thank you.